Scientific research shows that life could exist in many places across the universe. Maybe it's beyond our observation. Perhaps in this vast universe, humans are not the only intelligent beings that exist. But the chance of finding aliens still seems very slim. The origin of life is the process by which living organisms arose from non-living, inorganic matter. Spontaneously forms under certain suitable natural conditions and develops into simple organic compounds. Of course, many details of this process remain unclear to this day. And scientists still haven't been able to pinpoint exactly how they managed to escape so easily. Here are the natural English translations for your Vietnamese text. Religions around the world hold diverse perspectives on the origin of life. Of course, they always believed that this entire universe was crafted by the miraculous hands of supernatural forces. But those explanations are merely imaginative myths lacking any solid basis. Many of us don't feel truly satisfied. Origins remains one of humanity, and forces scientists to relentlessly seek answers. Tomonori Totani is an astronomy professor at the University of Tokyo. Was also swept up by those ideas. He wrote an article titled, "Life Emerges in an Expanding Universe," published in the journal Scientific Reports. Professor Totani's research is based on two factors that interact with each other. First is the age and scale of the universe. The expansion of the universe and the pace at which any events occur within it. To determine the sequence of a nucleotide strand, how long does a passage need to be to enable effective self-replicating activity? Professor Totani's research is similar to the majority of studies on the origin of life. Studies consider RNA one of the fundamental components that make up life on Earth. Also known as ribonucleic acid, DNA has a much more complex structure than RNA. It holds a wealth of information about the life-forming process of each individual. However, RNA is still more complex than any chemical compound that could exist outside of Earth. And precisely because RNA has a simpler structure than DNA, RNA has a higher ability to self-assemble. Additionally, an evolutionary hypothesis also proposes the view that, although DNA contains the genetic information that governs the formation process of an organism, but RNA is the key factor regulating the transcription of DNA sequences. The RNA world hypothesis proposes that RNA was the subject of natural selection. In the theory of polycentricity, powers can be divided and also have the capacity to shift flexibly. Therefore, if a comparison between RNA and DNA is needed to identify the first biological component formed from the primordial elements of the universe, we should choose RNA. RNA is a molecule composed of a chain of nucleotide monomers. Numerous studies indicate that a nucleotide sequence requires a minimum of 40 to 100 nucleotides to function effectively. Before the replication process occurred, it created the conditions for life to sustain and thrive. It takes quite a bit of time to gather enough nucleotide molecules. Only then can it form a chain long enough to meet the minimum requirement. The question is whether the universe has existed long enough for life like this to have formed or not. The universe has existed for over 13 billion years, and yet here we are. Of course there is. According to the press release of the newly published study, current estimates suggest that only 40 to 100 nucleotides are needed to create life, a truly magical number. It cannot exist in any regions of the universe that we can observe. The key point is this: so what about the space we can't observe? The universe is truly far vaster than the portion humans can perceive. Professor Tertanen said, "In modern cosmology, the universe underwent a period of extremely rapid expansion. Expand in area, so vast that it far exceeds our direct observational reach in space. Including larger areas in models studying the origin of life expands the scope of investigation and enhances the accuracy of results. Significantly increase the likelihood of life forming. Our universe was formed from a colossal explosion, commonly known as the Big Bang. According to numerous studies conducted by Professor Tertanen, the universe may contain more than 10 to the power of 100 stars similar to the Sun. The observable universe currently contains only about 10 to the power of 22 stars. We all know that life has appeared at least once. So, even though the chance is extremely slim, it's not surprising that it happened again. According to statistical data on the amount of observable matter in the universe, the synthesis can only produce RNA with a length of 20 nucleotides, which is much shorter than the range of 40 to 100 nucleotides. However, due to the rapid expansion of the universe, most of its expanse lies beyond the observable reach of humanity. This means the immense distance has prevented the sunlight emitted since the Big Bang from reaching Earth. When cosmologists calculate the total number of stars in both the observable and unobservable universe, the resulting figure is equivalent to 10 to the power of 100 stars with characteristics similar to the Sun. This means that a significant amount of matter still exists in the universe, creating favorable conditions for the formation of RNA chains. Not only is it feasible, but it has already happened, and this is certain to occur. In the research project, Professor Totani stated that he focused on exploring fundamental relationships. The quantification of chemical interaction is determined based on the minimum length of the RNA molecule required to form the polymer chain, the first biological polymer, and the size of the universe required to produce an RNA strand long enough to give rise to life. Based on the addition of monomers, the building blocks of polymers. They followed along this far and feel you understand the issue clearly. This is Professor Tominori Totani. If in the future, we discover extraterrestrial life with an origin different from humanity, this implies that there was some cognitive mechanism in place that enabled the polymerization of nucleotides faster than the process of random sampling. The actual universe is far vaster than the portion we can observe, and can contain up to 10 to the power of 100 sun-like stars. If the probability of a biogenic RNA formation on an Earth-like planet is 1, the minimum nucleotide length must be shorter than 20 nucleotides, significantly lower than the initially mentioned minimum threshold of 40 nucleotides. But scientists believe RNA cannot replicate on its own with only 20 nucleotides, at least in the way we perceive it when observing